From moon landing to satellite launching, NASA has been doing a pretty great job in their field of research and exploration. Their earlier prediction about the asteroid also came to be true, but now, NASA has been reported to have detected something quite massive just above our planet, and people all over the world can't seem to explain it. But what is this thing? Is it another planet? Or is it an asteroid? Is it something to worry about? Continue watching the video till the end to know more. Hey everyone, and welcome back to yet another video from our channel. We hope you guys are doing extremely well. In this video, we will be talking about something massive above our planet that has been detected by NASA. We will be diving deep into every aspect of this news, so if you are new to this channel, then make sure to hit the subscribe button. Now, without any further ado, let's hop right into the video. NASA's Spitzer Space Telescope has revealed the first known system of 7 Earth-sized planets around a single star. 3 of these planets are firmly located in the habitable zone, the area around the parent star where a rocky planet is most likely to have liquid water. The discovery sets a new record for the greatest number of habitable zone planets found around a single star outside our solar system. All of these 7 planets could have liquid water, key to life as we know it, under the right atmospheric conditions, but the chances are highest with the 3 in the habitable zone. This discovery could be a significant piece in the puzzle of finding habitable environments, places that are conducive to life, said Thomas Zurbuchen, Associate Administrator of the agency's Science Mission Directorate in Washington. Answering the question, are we alone, is a top science priority, and finding so many planets like these for the first time in the habitable zone is a remarkable step forward toward that goal. At about 40 light-years, 235 trillion miles, from Earth, the system of planets is relatively close to us, in the constellation Aquarius. Because they are located outside of our solar system, these planets are scientifically known as exoplanets. This exoplanet system is called TRAPPIST-1, named for the transiting planets and planetesimal small telescope, TRAPPIST, in Chile. In May 2016, researchers using TRAPPIST announced they had discovered 3 planets in the system, assisted by several ground-based telescopes, including the European Southern Observatory's Very Large Telescope. Spitzer confirmed the existence of 2 of these planets and discovered 5 additional ones, increasing the number of known planets in the system to 7. The new results were published Wednesday in the journal Nature and announced at a news briefing at NASA headquarters in Washington. Using Spitzer data, the team precisely measured the sizes of the 7 planets and developed first estimates of the masses of 6 of them, allowing their density to be estimated. Based on their densities, all of the TRAPPIST-1 planets are likely to be rocky. Further observations will not only help determine whether they are rich in water, but also possibly reveal whether any could have liquid water on their surfaces. The mass of the 7th and farthest exoplanet has not yet been estimated. Scientists believe it could be an icy, snowball-like world, but further observations are needed. The 7 wonders of TRAPPIST-1 are the first Earth-sized planets that have been found orbiting this kind of star, said Michael Gillen, lead author of the paper and the principal investigator of the TRAPPIST Exoplanet Survey at the University of Liège, Belgium. It is also the best target yet for studying the atmospheres of potentially habitable Earth-sized worlds. In contrast to our Sun, the TRAPPIST-1 star, classified as an ultra-cool dwarf, is so cool that liquid water could survive on planets orbiting very close to it, closer than is possible on planets in our solar system. All 7 of the TRAPPIST-1 planetary orbits are closer to their host star than Mercury is to our Sun. The planets also are very close to each other. If a person was standing on one of the planet's surface, they could gaze up and potentially see geological features or clouds of neighboring worlds, which would sometimes appear larger than the Moon in Earth's sky. Planets may also be tightly locked to their star, which means the same side of the planet is always facing the star. Therefore, each side is either perpetual day or night. This could mean they have weather patterns totally unlike those on Earth, such as strong winds blowing from the day side to the night side and extreme temperature changes. Spitzer, an infrared telescope that trails Earth as it orbits the Sun, was well suited for studying TRAPPIST-1 because the star glows brightest in infrared light, whose wavelengths are longer than the eye can see. In the fall of 2016, Spitzer observed TRAPPIST-1 nearly continuously for 500 hours. Spitzer is uniquely positioned in its orbit to observe enough crossing transits of the planets in front of a host star to reveal the complex architecture of the system. Engineers optimized Spitzer's ability to observe transiting planets during Spitzer's warm mission, which began after the spacecraft's coolant ran out as planned after the first 5 years of operations. "This is the most exciting result I have seen in the 14 years of Spitzer operations," said Sean Carey, manager of NASA's Spitzer Science Center at Caltech IPAC in Pasadena, California. Spitzer will follow up in the fall to further refine our understanding of these planets so that the James Webb Space Telescope can follow up. More observations of the system are sure to reveal more secrets. Following up on the Spitzer discovery, NASA's Hubble Space Telescope has initiated the screening of 4 of the planets, including the 3 inside the habitable zone. These observations aim at assessing the presence of puffy, hydrogen-dominated atmospheres, typical for gaseous worlds like Neptune, around these planets. In May 2016, the Hubble team observed the 2 innermost planets and found no evidence for such puffy atmospheres. This strengthened the case that the planets closest to the star are rocky in nature. The TRAPPIST-1 system provides one of the best opportunities in the next decade to study the atmospheres around Earth-sized planets, said Nicole Lewis, co-leader of the Hubble study and astronomer at the Space Telescope Science Institute in Baltimore, Maryland. NASA's planet-hunting Kepler Space Telescope also is studying the TRAPPIST-1 system, making measurements of the star's minuscule changes in brightness due to transiting planets. Operating as the K2 mission, the spacecraft's observations will allow astronomers to refine the properties of the known planets, as well as search for additional planets in the system. The K2 observations conclude in early March and will be made available on the public archive. Spitzer, Hubble, and Kepler will help astronomers plan for follow-up studies using NASA's upcoming James Webb Space Telescope, launching in 2018. With much greater sensitivity, Webb will be able to detect the chemical fingerprints of water, methane, oxygen, ozone, and other components of a planet's atmosphere. Webb also will analyze planets' temperatures and surface pressures, key factors in assessing their habitability. NASA's Jet Propulsion Laboratory, JPL, in Pasadena, California, manages the Spitzer Space Telescope mission for NASA's Science Mission Directorate. Science operations are conducted at the Spitzer Science Center at Caltech in Pasadena, California. Spacecraft operations are based at Lockheed Martin Space Systems Company, Littleton, Colorado. Data are archived at the Infrared Science Archive, housed at Caltech IPAC. Caltech manages JPL for NASA. However, this churns out the question, is life beyond Earth a possibility? The search for life beyond Earth is really just getting started, but science has an encouraging early answer. There are plenty of planets in the galaxy, many with similarities to our own. But what we don't know fills volumes. Observations from the ground and from space have confirmed thousands of planets beyond our solar system. Our galaxy likely holds trillions. But so far, we have no evidence of life beyond Earth. Is life in the cosmos easily begun and commonplace, or is it incredibly rare? The universe's eerie silence has its own name, the Fermi paradox. Physicist Enrico Fermi famously posed the question, where is everybody? Even at slow travel speeds, the universe's billions of years of existence allow plenty of time for intelligent, technological life forms to traverse the galaxy. Why then is the cosmos so quiet? Meanwhile, exoplanet discoveries over the past 2 decades have filled in a few of the terms in the much-debated Drake equation, a chain of numbers that might one day tell us how many intelligent civilizations we can expect to find. Most of its terms remain blank. The fraction of planets with life, with intelligent life, with detectable technology. But the equation itself suggests we might one day arrive at an answer. It feels at least a little more hopeful than Fermi's silence. We stand at a crossroads in the search for life, found thousands of planets in our Milky Way galaxy, a large fraction of them in Earth's size range and orbiting in their star's habitable zones, the distance from the star at which liquid water could exist on the surface. We know the galaxy likely holds trillions of planets. Our telescopes in space and on the ground, and our remote sensing technology grow ever more powerful. Yet so far, the only life we know of is right here at home. For the moment, we're staring into the void, hoping someone is staring back. And that's all for today. Did we miss out on anything? Do you have any other insights on this news? Did you enjoy watching the video? Let us know your thoughts in the comments section down below. Well, it brings us to the end of this video. We hope you have enjoyed watching the video. Please like the video if you have not already and make sure to hit the subscribe button. Don't forget to press the bell icon to never miss another update from our channel. With that being said, let's meet in another one of these videos. Until then, see ya!